Welcome everyone. In this video class, we shall learn about the recursive function and its meaning. Now, by definition, we can say recursion is a process by which a function calls itself repeatedly until some specified condition has been satisfied. So basically, you can have an example like this where you will have a function named sum, okay, but inside this sum you are also again calling a function. Of course, we from the main we are going to call this function to invoke this function, okay, it's by giving sum in this way. So that's a function call, a normal function call. But when we call this function, you see that inside this function it's again calling itself. So this will repeat like a loop in this way, okay. So this is what we call as recursive function. And another example would be somewhat in this way. Again, I would call someone, so it comes to someone in this way, and then this someone will call sum2, and in sum2 again it's calling someone. Again, this someone, it comes here and then it calls the sum2, and sum2 comes back and then it calls the someone. So again, like a loop. But the first example is also called as the direct recursion, meaning we have a function and that function calls itself directly. So that is a direct recursion. But the second example, you will see that this function is not calling itself, but rather it's calling a function which calls that function. Okay, so it's just like I'm calling a function which will call my function, right? So that is what we say, or we call it as indirect recursion, right? Now these two things you have to remember in order to solve a problem recursively. Okay, we have two conditions that we need to have, meaning that if your program you're trying to solve it recursively, then these two conditions should be applied. Number one, the problem must be written in a recursive form. Recursive form, now you understand what it means. It means that you have to call itself. That is also called as recursive case. Then the second, the problem statement must include a stopping condition, and this condition must be reachable, meaning that it has to come to an end. You see that when you call a function, okay, it keeps on calling and becomes like a loop non-stop. But if you want to have if you want to do this in your program, you need to have this second one also, which means you need to stop that, okay, somewhere somehow. And this is, yeah, we can do this by a base case, okay, which we're going to talk about later. Now, if you see in the first, when we say the problem must be written in recursive form, that is recursive case, it means that we are just calling in this way. We are calling ourselves. So from the main, you will call F1. So F1 is a function. And in this function, you're printing Christian Academy, and then you're calling again F1. So of course, again, it's going to print Christian Academy. Again, you're calling it. Again, it will come to this function and it will print Christian Academy. So of course, this is recursive case, and also it's going to be infinite. That is, it's not going to end. It'll keep on printing Christian Academy, right? Now, again, if you recursive case, it means that we have a function which is in this way, like an indirect function, recursion, okay, where f1, okay, we of course we need to invoke one function, okay, we need to call it, so that we invoke it. Now once we call f1, then we print Christian Academy, then you call f2, and in f2 you're saying print Christian Academy again, and then it calls f1 again, it prints Christian Academy, and again it calls f2, and f2 again it's printing Christian Academy. And this way, this also will be like a loop, and this also will be an infinite, okay, which means this program will run endlessly, okay, so you won't be able to stop, right? So that's why we need the second point. The problem statement must include a stopping condition, okay, which means we need to stop it, okay, using a base case. Now how do usually we come out of a function? That is using a return. We know that the moment you say return 1, then it comes out forcibly from any function. Any function, if you just give return, return 0, return 1, return n, return any variable also, when you return an expression or anything, it comes out of the function, right? So we are going to use this kind of technique for the base case that will stop the recursion, okay? Now You will see this example about finding a factorial about a number. Now when I say factorial of a number, it means if I say find the factorial of 3, it means 1 into 2 into 3. Okay, that means 1 into 2 is 2, 2 into 3 is 6. So factorial of 3 is 6. If I say factorial of 4 again, it will mean 1 into 2 into 3 into 4. So these kind of problem where we have, a very continuous way, in this way we can always go for a recursion. It's just like there are many problem, okay, we can solve, okay, using a Python program, but then Python code, but then not always all that we can do so using a recursion. But if you have a problem like this where we have 1 into 2 into 3 into 4, or you have to add 6 plus 6 plus 6 plus 6, or any other problem, okay, which you can solve recursively, then you can use a recursion. Okay, so factorial is 1, because if I say factorial of 4, it'll mean 1 into 2 into 3 into 4, right? So you'll understand better as we go, right? So let's just have a look at this program, what it's doing. First of all, we start with the main. This is the main num int, input enter number. So you're asking a number, and this number is stored where? In num. Immediately after that, you're trying to print something, and you're calling this function, and you are sending num also. So let's assume that this number that you got from here, okay, is 5. So basically you're sending what to factorial? You're sending 5. Then you check if 5 is equal to 1. No, it's not equal to 1, so it's not going to return n. It comes to the else part where you're trying to return 5, but then you are multiplying with something, and that something is, again, you're just like you're telling, please go to this function again. And what is this function? Factorial is your own function. So this is recursion. You are calling again, but this time, have a look, you are not sending the same value, that is n, which is 5. You are sending 5 minus 1 if the number is 5. Okay, so that would mean you're sending 4. So basically this is what we call as recursive function. So the first point is solve. The first point that your program is calling itself, so it's recursive. Okay, so recursive case, you have done it. Then after that, what happened to this 5? Because the moment you said multiply and then you are calling a function, it gets stored in a stack, right? It gets stored there, and then again it calls this factorial, and you're sending another number, and that is 4, okay, to factorial. And again this 4 is not equal to 1, it will not return n, it comes to the else and then it returns 4 again. Before it does anything, you're saying 4 into, again you're calling factorial, so this 4 will be again stored in a stack. Okay, and again you're calling factorial, so 3, the next one will be 3, you're sending 3, and this 3 again, it will check if it's equal to 1. No, it's not equal. Again it's saying 3 into factorial, so 3 again will get stored where? In the stack. Okay, and then you're calling factorial, so 2 will come, same way will happen. But after 2 into factorial, okay, when 2 gets stored in a stack and you're calling this factorial, 2 minus 1 you're sending, so that means 1. When you're sending 1, okay, that's when you will see that this is equal to 1, n is equal to 1. That's when you're going to return n, and n right now is what? Equal to 1, so it is 1, so you are putting 1. Okay, so you're returning 1, and this what exactly happens in recursion. It doesn't just go straight away to your main program and print that 1 or print that 2 or anything, nothing like that. It gets stored in a stack, and it comes out one by one. Okay, it comes out in this way, which means 1 first will come out, okay, then 2, then 3, then into 4, into 5. So it's like you're saying 1 into 2 into 3 into 4 into 5, which is 120. So what you're printing here will be 120. So this program will simply print 120. Of course you can write the factorial of num to just 5, okay, previous num is, then you simply have to call that factorial and the number will come here. This another way to do this is that you simply call factorial num, and in the next line you store that in one variable and you print that variable as I've showed you earlier. Okay, you can do that also. So this is one example of a program you solving using a recursion. Okay, that is a recursive function, right? Now, these are other cases that you need to remember. It is a more recursive case. It is more general case of the problem we are trying to solve using recursive call to same function. But when we say base case, now if you just have a look at the previous in this program, now you can make out which one is the base case. The base case is this part, okay, where you're stopping the recursion. Otherwise it'll keep on calling factorial, keep on calling factorial, isn't it? But then by putting this, if n is equal to 1, then return n. You're not calling anymore, you're not calling the function anymore, straight away it comes out, okay, unlike this one. So that's why this part is your base case, okay. And base case, by if you have to write in detail, you can also write in this way. It is a small problem that we know how to solve, because you know already that if I say if n is equal to 1, okay, I'm going to put an n, okay, to this, and is the case that causes the recursion to n. It is the case whose solution is pre-known, you know already, okay, either as a value or formula, because you know, you say n is equal to 1, so you're using 1, okay, and you already know it, okay, and you're using it directly. So that is a base case, right? Now a little about how these things are being stored, okay. Normally when we put a number, okay, when you store a number in, then it is when you execute them, usually it comes in this way, okay. Whatever you have put, the first one will get executed first. But when you do this with recursive function, that is recursion, the function are executed in reverse order. Why? Now during recursion, the recursive function calls are placed on a stack, just I have showed you that factorial, okay, until the condition that terminates the recursion is encountered, that is if n is equal to 1 and you're returning that 1. So the function are then executed in reverse order, which means you have a stack like this, okay, all the numbers, and remember that the last one which you have kept, that will come out first. So I've already showed you with that factorial how that 1 first will come, not the 5 you kept it first, but then it's not going to come first, okay. The last one that you kept, that will come out, okay. So remember, with stack, if you're asked recursion use what data structure, it use a stack data structure, please note down, okay. And also in a stack data structure, they always follow the last in first out. Remember, last in first out. Now this is a very important point, okay, that you need to remember. When a recursive program is executed, the recursive function calls are not executed immediately, right? So when that 5 came, 4 came, okay, all right, it was not executed, rather they are placed on a stack until the condition that terminates the recursion is encountered. So the function calls are then executed in reverse order as they are popped off the stack. So with this, I hope you have understood the introduction part of the recursive function, okay, and how and where you can use. There are some programs that you can use a recursive function. Now in the next class, I'm going to just explain to you in detail about the recursion versus iteration, because it's similar. As you can see that it keeps on calling and then it becomes like a loop. So iteration means looping, where we have the while loop, the for loop, right? And how you distinguish, or what is the similarity between them, right? So with this we come to an end, okay, and I hope you are clear. Thank you.